So the last time we saw how we have been given equation and we're supposed to find the radius and the center of the equation. Okay, so we're given such equation like this. So this time around we're going to tackle a question of that sort. So now let's look at the question. Okay, there's a question here that says find the radius. The question is find the radius and the coordinates of the center of the circle with equation, with known equation, with an equation s squared minus 3x plus y squared plus 4y minus 12 is equals to 0. You see, as I said before, this is always two quadratic equations in one. Okay, two quadratic equations in one. So if you look at it very carefully, you see we are going to solve this. Let's solve it. As I said, it's always two quadratic equations in one. Okay, so you see that we have one with all s squared, and all of them have coefficient a to be equals to 1. So to solve this, we say that the first one for the x will be x, okay, x minus, you see the 3 over here, we divide it by 2, and we square it, okay. Then after that, we have minus, we say minus the same 3 over 2 squared, plus here we say y plus 2 squared minus 2. Over here, so we have 2 divided by 2. So that will be minus 2 squared minus 12. Okay, and if we solve this very well, you see that we can separate all the x's and y squares. So here we are going to get x minus 3 over 2 squared. Okay, then we'll bring this one here. So we say y plus 2 squared. Okay, y plus 2 squared. Okay, then let's take our time. I hope everybody's been looking at, gathering the idea, so it's not anything difficult. So when we finish, okay, we bring the 12. So we have here, we have a 12. Okay, then we know that 3 over 2 squared, when this one, we bring it here. Okay, so that'll be plus 3 over 2 squared. And here, we bring our 2 over 2 squared. So when we take the time and you write it nicely, you see, this implies that x minus 3 over 2 squared plus y plus 2 squared is equal to 12. Okay, and this will be plus 9 over 4. Okay, plus 4. Alright, when we compute it very carefully, we are going to get minus 3 over 2 squared plus y over 2 squared is equals to 73 over 4. Friends, so straightforward. If we compare this equation to our general quadratic equations, x minus a squared plus y minus b squared is equals to r squared. You see, with this comparative step, we will see that our a, which is the center for the x, is equals to 3 over 2, okay? And our b will be equals to what? Negative 2. And our r squared is equals to 73 over 4, okay? Now, it means our center of the equation is 3 over 2, comma negative 2, okay? And r is equals to square root of 73 over what? 2. So this is the what? The center, and this is the radius. So you see, we are able to use our quadratic equation approach. You see, so what we did, you see, is dividing this by 2 and dividing this by 2 and squaring that. And whatever we did, we add to both sides of the equation as well. Have you seen that? So x minus 3x, so divided by 2, all into bracket squared, and minus 3 over 2, okay, we compute. As you said, that's minus, and we come here 2 minus of that. All right, we subtract minus b over 2a squared to both sides of the equation. You see, that's all here. You see, if you look at it, all what we have done is we have added negative b over 2a squared to both sides of the equation. You understand? So it's not anything difficult. You see, that is the reason why I say for our c is equals to what? A squared plus b squared minus r squared. Okay, and we can use this one to calculate the center. So this is one example. I think let's see what if we can solve one more before we finish for the day. Okay, let's try and see. Okay, so now let's go down and see how we can solve similar one. Okay, I hope this is not anything difficult. Okay, so first of all, you have to do that. Negative b over b, negative b over 2a squared from both sides, and that will give us the solution to this question. So this whole question, okay, the whole question, take your time and look at it. You see that it's not anything difficult. You just follow stepwise and you'll be smiling. Okay, look at this question. Okay, all right. So friends, I'm gonna leave you guys here. Okay, until we meet again. Bye. Go through it.